Hi everyone, we'll be starting with the session. Hello everyone, good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 7A. Myself Anshika Jain and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundations and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Intelligent Systems ICTIS 2025 New York, USA. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in New York, USA, and the virtual event is being held through Zoom yesterday and today, that is 23rd and 24th May 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 8 presentations, and each presenter will be given 12 minutes for the presentations and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or any updates, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for this session, Dr. Elias. Dr. Elias Tebane is a senior lecturer at the University of South Africa, specializing in information systems. His research encompasses IoT, artificial intelligence, big data analytics, digital skills, IT governance, and 4IR. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Good afternoon, everyone. Good afternoon, Chair. I'm just looking for a robust session with all of the participants, and good luck with your presentation. Thank you.
Thank you so much, sir. I would also like to introduce you all to the session chair, Dr. Neha Tiwari. Ma'am is working as an associate professor and additional head in the Department of Computer Science and IT at ISS Jaipur. She is a research supervisor with the experience of more than 16 years and has also supervised the students in a variety of projects. Her research domains include networking, machine learning, blockchain, databases, software engineering, and cloud computing. Welcome to the session, ma'am. Would you like to share a quick opening remark with us?
I'm humbled with the introduction, Anshika. Thanks a lot. And all the best to the presenters. Looking forward to the sessions.
Thank you so much, ma'am. So we'll be starting with the papers now. First, we have Syed to present the paper title, A Novel Hybrid Method for Enhanced Brain Signal Analysis Using EEG and MEG. Are you there?
Yeah, and thank you very much. I'm here
Yeah, you
listening
may
to
please
you.
begin with your presentation now.
Okay, so I'm sharing my screen
Yeah, you can
and
start sharing. I am unable to see your screen. Yeah.
now it's visible.
Yeah, you have started sharing the screen. Yeah, we can see it. You may start.
Okay, thank you very much. So my name is Raza Abdi, and I'm working as a postdoctoral researcher at Dublin City University, Ireland. So today the topic of my presentation is I'm presenting our paper has a title, A Novel Hybrid Method for Enhanced Brain Signal Analysis Using EEG and MEG. So about the design, because MEG and EEG experiments typically involve the presentation of a stimuli. So MNE, it's a Python library that comes with the plenty of data sets that we can use to test, train, analyze, and explore the functionality of MNE data sets. So in this study, we actually use this sample data set, which is publicly available over the internet. And in this data set, we have the MEG, EEG, and EOG recordings from one subject, and the combined MEG and EEG conducted simultaneously. The objective of the study is we have two objectives to actually run this study. The one is designing a novel hybrid method using machine learning to identify the combining data from different modalities make the prediction more robust to noise and artifacts present in individual modalities. So these are two different modalities the data is coming from. For example, EEG and MEG. These are two types of sensors. I will explain you in the next slide. So the second objective is to propose a machine learning based pipeline methodology for EEG and MEG data analysis targeted at investigating brain functions, which improves the precision during data interpretation for diagnostic purposes. So what is this is you can see the basics of the EEG and MEG. EEG and MEG basically electroencephalography and magnetoencephalography. These are two techniques which normally used in the brain study, or doctors or clinicians actually using these type of techniques to identify tumor and other neurological diseases. So uh, what is EEG? EEG is both techniques have the pros and cons. So as because EEG is highly temporal resolution, on the other hand MEG is highly spatial resolution. So EEG actually measures electrical activity via scalp electrodes. The electrodes are mounted on the head of the patient or the person, and the MEG detects magnetic field generated by neural activity. So these two are important, and these are two different techniques. So the objective is how to because we combine these two to see whether it has some benefit for giving us prediction. So I will explain you in the next slide. So uh, on the other hand, the EEG is the commonly used for detecting real-time neural activity, and the MEG is the non-invasive and used in source localization, as I have told to you about the detection of the tumor at other neurological disease. So uh, a simple illustration of EEG is sensors mounted on the head, and the MEG is the simple illustration of MEG scanner. So these are the advantages of combining two modalities. For example, if we combine, so number one is the enhanced accuracy, the temporal resolution, signal to noise ratio, which is very important in diagnosing the brain signals, and spatial resolution, and there are so many advantages available. So the objective is how we combine and get the benefit of these combining these two modalities. So the approach we have used in this paper, actually we used the MIND ACC approach, which is the stages of modality integration for neurosignals to enhanced accuracy. You can see here the first step is the orange one is starting from the pre-processing step, then filtering, then segmentation of the data. This is called epoching, and averaging of the target or standard stimuli, and then extracting the feature, and then applying the machine learning. So the sample data set actually consists of we collected a sample data set from the MNE Python library, and it was recorded in the Martinos Center for Massachusetts General Hospital. And the task is basically the checkerboard patterns were presented into the left and right visual field of the patient. Patient is sitting in front of the screen, and checkerboard patterns were presented to identify and press the button when the patient sees the checkerboard patterns in the left or right visual through their eyes. So and also it is interspersed by the tones to the left or right ear. So this data set has also cover the visual and vocal uh, tones and data sets. So at the moment, actually, we have you can see here there are on the right figure you can see the stimulus present in this data set. So there are visual and vocal stimuli are present with the smiley face. So you can see we use the raw data, which is 100 millisecond, and uh, uh, the lower frequency is 0.1 and higher frequency is 40, which is the standard. of analyzing the brain signals, and when epoching, we have created the minimum window of -0.3 to 0.5, baseline none 0, and total events we observed is 320, because we only focus on the visual events, which is visual left and visual right. And the events presented in this experiment is 73 and 71. So total is 144. So these are some evoked plots, stimulus plots, which we average those epochs, those segmented data. For example, we are using only the visual left and visual right stimuli. So the total is 144, and we average them. And the topo map above this graph is showing that there is no artifact present or available in this data, because we have cleaned the data up to some extent. So averaging is actually the procedure which we remove the artifact from the signal. So there are different timestamps: 0.0 second, 1 second, 0.2 second. So you can see, and this is the good display for identifying at which time point we have some anomalies. So these are again the evoke plotting on the left of chart. You can see the above the top figure is related to EEG. The middle one is gradiometer, and the last one is a magnetometer. So these are two different types of sensors using in this experiment. So on the right side, you can see there is a baseline dotted line which shows the minus 0.3 to 0.5. So you can see after the baseline, there is a stimulus available. You can see on the right figure. So this is the machine learning metric we have used. For example, we use the MNE decoding, which is the library for analyzing the machine learning tasks. So, and the pipeline we used scalar, vectorizer, and classifier. And the classifier we used is the logistic regression, and cross validation we use the CV equal to 5. And the scoring criteria we use is the ROC AUC. So which is the standard for the classification task. So this is the outcome table of the machine learning task. So if you see, the first column is the brain sensor data, and second one is the ROC AUC mean percentage, and the third one is the standard deviation. So you can see here, if we apply only, if we handle only the EEG sensor, so we can get 88.4% of the accuracy. And for example, if we deal with the different sensors, for example, MAG and grade individually, so it gives us the different percentages. But if we combine, for example, EEG and MAG, 98.8, EEG and grad, which is the highest one, 99.8, and MAG and grad. So, and if we combine these three, for example, EEG, MAG, and grad, because these are the sensors, so 99.5. So here we observed that after combining the EEG and grad, we can get 99.8% accuracy with the 0.002 standard deviation. So these are some cross-validation scores for the visual left and right stimuli. For example, if we use, I have pasted the three figures. The left one is showing that EEG and MAG. The middle one is EEG and grad, and the third one is the combining of three modalities. So these are the applications which we can use these two modalities together to develop some application. For example, if we are dealing with the epilepsy patients or the brain-computer interfaces or the cognitive neuroscience, so this could be helpful in identifying the patterns and neurological diseases. So this is our team. On the left, myself, and in the center, Professor Gabriel, which is my primary supervisor at DCU, and Professor David Henschel, which is working as a director at Royal College of Surgeons in Ireland. Thank you very much.
Thank you so much for your presentation. Ma'am, do you have any questions, and sir?
Yes, am I audible?
Yes, ma'am, you are audible.
Yeah,
Ma'am Raza, I would like to congratulate you on a wonderful work that you've done. It's
thank you.
really shows promising, growth in social cause, I would say. The implementation
Yeah.
would be benefits to many. My questions to you are two. Firstly, what's the size of the data set that you've taken for the work?
Yeah, because at the moment we have taken the one patient data set from the sample from the public data set, and if we combine the other, we are trying to combine other patients data set to basically to test that is it worthwhile working for the combining the modalities or not. So at the moment we are dealing with the one subject.
Okay, so you took some the data belongs to some real life like patient. Is he like undergoing
Yeah.
such? Okay,
Yeah, yeah,
and
definitely, because the data actually conducted at the Massachusetts General Hospital in USA,
yeah, you
and you know
mentioned that. Yes.
it is publicly available over the internet and in inside the MNE Python library, which is a big library and tool available. So it's a standardized patient data.
Yeah, so I think you don't have any repository where you have, lots of data because it's really going to make a difference in the results which you've got. I'm sure of it.
Yeah, so definitely because MNE actually MNE itself giving us the repository where we can actually through the commands and by invoking some commands we can access the data from the MNE Python library, which is inbuilt available at the website of the Python.
Yeah, but when we increase the size of the data set, I think it's really going to make some difference with the results,
Yeah,
right? Yeah.
yeah, definitely. Because the same analogy we are actually trying to apply here in Ireland, in the Beaumont Hospital, where we have almost 15 patients, and now we are trying to actually replicate this to see whether it can make effect or not.
Yeah. And secondly, I want to ask, can you tell me certain challenges which you faced or you could face while implementing it through, I would say, some devices or maybe, through any other way? So, can you just brief us about the challenges which you expect and challenges which you faced?
Yeah, basically the first challenge is because in this type of data set, you have to assign the epoching scheme, which is, very difficult sometimes because smiley face is presenting at random time, right? In front of because the patient is sitting in front of the computer and identifying the smiley face. So sometimes there are some garbage values and anomalies available in the data set while observing the data. So we first actually analyze the data set, remove the anomalies and the noise, which is the prime concern. So basically, if we cannot remove the noise, so the result will definitely be changed.
Yeah,
So
thank you.
yeah, so main challenge is about the how to identify how to apply denoising techniques, which is we applied IC at the moment, which is the very common technique for analyzing the brain signals.
All right. Thank you so much and all the very best to you.
Thank you very much, Neha. Thank you.
Thank you so much, ma'am. Sir, do you have any questions?
Yes, mine is just a recommendation that doctor should also check some other deep learning modules or algorithms because now he's doing everything at the postdoctoral level. So also if you can check the algorithm like hybrid CNN plus LSTM and some models like your transformer models, deep C, and then see how that model performs with the same data which is currently using so that the contribution at the postdoctoral level can be much significant versus for the undergraduates. That's my recommendation to the doctor. Thank you.
Yeah, yeah, definitely, Elias. Thank you very much for your recommendation. And we are planning to actually apply the transformer, which is the LLM technique. So definitely your suggestions will be highly appreciated.
Pleasure.
Thank you so much. So we'll be moving
Thank you
on
very much.
to the next presentation now. Next, we have Ahmed to present the paper title, An Ensemble Deep Learning Framework for Two-Stage Diabetic Retinopathy Diagnosis and Severity Screening. Are you there?
Yes.
Ahmed?
Am I audible and visible?
Yeah, you're audible as well as visible. You may please begin with the presentation.
Okay. Let me share my screen. Is it visible?
Yeah, we can see your screen. You may please begin.
Hello everyone, and good afternoon to New Yorkers. And here in Bangladesh, it's just past 10. I'm Ahmed from ICTIS University presenting our paper on ensemble deep learning framework for two-stage diabetic retinopathy diagnosis and severity screening. I'm thankful to the jury for giving me the space. These are the outline. This is the outline, and which I'm going to cover throughout this presentation. We all know that diabetes mellitus is a global epidemic, and which causes many diseases, and diabetic retinopathy is one of them. And in this world, around 400 million people are affected with diabetes mellitus, and among those, one third of them are suffering from diabetic retinopathy, including my father, sadly. And it is expected to reach the 160 million mark around 2045. Non-proliferative DR and proliferative DR are the main two types of diabetic retinopathy, and non-proliferative can be disseminated into mild, moderate, and severe DR. It is also known that there is a scarcity of ophthalmologists, not only in the rural areas, but also in the cities. And manual detection of diabetic retinopathy is quite costly and time intensive. Also, in the current state of research, there is a lack of balanced dataset, and which also causes the overfitting problems in existing models. So our objective is to reduce the challenges faced by individuals and ophthalmologists by developing a deep learning framework for the efficient detection of diabetic retinopathy at an early stage. So we have covered some literatures, and here's the gist. And we found that CNN, InceptionNet, ResNet are some of the common used deep learning architecture in detection of diabetic retinopathy. And Aptos 19, Messidor, IPEX are the common dataset used. Some key challenges we found that there are most of the models are susceptible to data leakage, and because of the data inefficiency or diversity, the most of the models are biased towards detecting no deer or moderate deer. And also the performance of the model shows that they are lacking, they are weakness in generalization. This is our proposed framework which has been followed in our research. Firstly, we have merged three data sets and then use use only the DR and no DR class to detect the binary classification. To do the binary classification to detect the existence of DR. If it is DR positive, then we have passed it to the severity analysis, where three state-of-the-art models has been utilized, and their prediction has been incorporated with a weighted average strategy to get the final severity. Our dataset is a merged one where we gathered around 6,000 images from Messidor 2, Aptos 2019, and IDR-ID. And it is quite clear that from the table, the number of no-deer images is quite high than other classes, and it is clearly creating class imbalance. Before feeding the images to our models, we have incorporated three proposing methods. At first, we remove the low intensity backgrounds of those images and reduce noises. And in proposing one, we reduce the intensity of blue channel and red channel to 25%, and then the contrast enhancement were applied to the green channel. In proposing two, the green channels was extracted before increasing the contrast, and then it is converted to the grayscale. And in proposing three, it is a different kind of Benham's contrast improving method with customized parameters. In stage 1, the existence of DR was detected. For this, we segmentize our data set into two groups, like no DR and DR. So in that, the number of images in no DR and DR are quite close. So no augmentation was implemented. Thus, 70% of the images were allocated to training and 15 for validation and 15 for testing. Then the images were sent to the DenseNet model, which was pre-trained on ImageNet weight, and it is connected to a custom classification head. The training was run for 50 epochs with a batch size of 32. In the stage 2, here the severity has been detected, and here we only use the DR positive classes like mild, moderate, severe, and proliferative. No DR images were used. Uh, Here, we implemented some augmentation techniques to remove the class imbalance, and then the dataset was split into 70, 15, and 15% for training, validation, and testing correspondingly. Then the images were fed to three different models, DenseNet 121, exception, and EfficientNet D1. All of those were pre-trained on ImageNet weights, and then also added to a custom classification head. The training was run for 30 books and the batch size was 32 as before. The prediction of those three models were utilized and incorporated with a weighted average strategy to get the final prediction on the severity. So DenseNet 121 exception and EfficientNet D1 were not chosen only for their better performance, but also their unique characteristics. Let's say DenseNet 121 is very great at handling vanishing gradients by reusing its features, and in exception in exception model, it is quite good at employing depth separable formulation. And in EfficientNet B1, it can maintain a balance between the efficiency and accuracy with leveraging the compound scaling method. Here's the binary classification results, and it is quite clear that our model performed best on Aptos 2019 dataset on pre-processing 3, where the accuracy was 0.98, precision was 0.97, recall was 0.99, and finally the F1 score was 0.98, which is better than all the other models. But we are emphasizing on the merged dataset score because in the merged dataset there are different kinds of images which also uh, bolster the capacity of our model generalizability, where the accuracy is 0.92, precision was 0.89, recall was 0.97, and F1 score was 0.93, which is also much better than the other existing models. In the multi-class classification result, it is quite clear that EfficientNet B1 has a great score of reaching 0.93 in all the in accuracy, precision, recall, or in F1 scores, but our model slightly surpasses the EfficientNet B1 on recall and F1 score by 0.94. So we contributed by developing an ensemble-based deep learning framework where the diabetic retinopathy was detected by binary classification first, and then the multi-class classification were incorporated for severity grading. And we combined three data sets, Aptos 2019, Macedor 2, and IDR-ID, also incorporated three different kinds of pre-processing techniques. Also, the results we got through our model were compared to other state-of-the-art models, and every time our model performed better. And in future, we would like to increase our model's explainability by implementing explainable AI. Also, training on extended data set using different kind of reversing techniques is a must. And also by implementing the model to an IoT device would assist the medical professional in real world scenario. Thank you everyone for staying with me in this presentation, and I'm open for any kind of queries.
Thank you so much for your presentation. Ma'am and sir, do you have any questions?
No questions from my end because he has majorly covered all the pointers and kept the major points which should be considered in the presentation and in mine as well. So it's a good work overall.
Thank you, ma'am.
Thank you, ma'am.
Sir, do we have any questions?
Yes, so I just want to find out how did you dealt with the issues of the missing values, the outliers, and then also you spoke about overfitting. How did you address that in the whole
Yes.
study?
Yeah, in the first, we use in the binary classification, we didn't use any kind of augmentation method. So because of not using any kind of augmentation method, there is no error or no noise. So I think there is no overfitting problem in the binary classification. But if I say in the severity analysis, it is susceptible to overfitting, as I followed other research paper who work quite in the similar way.
Yeah, so also as a suggestion, I'll suggest that you also introduce the step whereby you do exploratory data analysis. You just also check the entire data on itself, and then you check if there are any imbalances. And then from that, when you do your correlation, you'll find that some of your data, there's some correlation there and there, and then also some missing values. You can just address them via Python and add some zeros or whatever dash you want to put there. Just a suggestion. But the overall work, I'm impressed. The work is excellent. Thank you.
Thank you. Thank you, sir.
Thank you so much for your presentation. So we'll be moving on to the next presentation now. Next up, we have Elvir to present the paper title, Computer-Based Solving of Partial Differential Equations Using the Method of Nets. Are you there? Elvir, are you there? Okay. I guess he's not here. So we'll be moving on to the next presentation. Next, we have Syed to present the paper title, Early Detection and Support System for Student Mental Health Using Machine Learning. Are you there? Syed, are you there? Okay, so we'll be moving on to the next presentation. Next, we have Alaya to present the paper title, Enhancing Cervical Cancer Diagnosis Through Explainable AI and Deep Learning Techniques. Are you there?
Yes, ma'am.
Yeah, you may please begin with the presentation. We can see your screen. You may please start.
Hello, this is Alaya Parvinalo from Daffodil International University, Bangladesh, where is our work titled Enhancing Cervical Cancer Diagnosis Through Explainable AI and Deep Learning Techniques. Let's start with the introduction. Cervical cancer is one of the most prevalent cancers affecting women worldwide. Despite being largely preventable through early screening, it continues to result in high mortality rates, especially in low resource settings. Traditional diagnostic methods such as histopathological analysis are effective, but often suffer from limitations. They are time intensive, require expert pathologists, and can be subjective. In response to these limitations, we turn to deep learning techniques, particularly CNN, which can learn complex patterns from images and automate the classification of cervical cells. However, these models are often treated as black boxes, which hinders trust in clinical environments. Our study seeks to address this by enhancing model performance and integrating explainable AI or XAI tools to provide insights into the model's decision making. Okay. The key problem lies in the delayed diagnosis caused by traditional manual methods. Not only are this process slow, but they are also highly dependent on human expertise, something not always available in rural or resource limited settings. Moreover, while deep learning models show exceptional performance in classification tasks, the lack of interpretability poses a serious barrier to clinical deployment. Medical professionals need to trust the model's decision and understand its rationale. This led us to Our central research challenge: how can we develop a system that is both highly accurate and interpretable enough to be used in real-world clinical settings? Our motivation was deeply rooted in the public health implications of cervical cancer, particularly in under-researched regions. We found a solution that not only automates diagnosis but also builds confidence among medical professionals. The objectives of our study were threefold. First, to evaluate multiple CNN architectures for cervical cell classification. Second, to fine-tune the best performing model to achieve state-of-the-art accuracy. And third, to apply explainable AI techniques such as line and saliency maps to ensure the model's predictions are understandable and verifiable by healthcare. Our work builds upon a rich body of literature. For instance, you can see Davy et al. Explored artificial neural networks and highlighted the ratio as a critical feature for cancer detections. Some introduced a pipeline combining cervix detection and classification using deep CNNs with extreme learning machines to achieve 99.7 accuracy in binary classification. Other studies compared machine learning models like random forest and SVM against deep learning models such as ResNet 50, with deep learning generally outperforming. However, a consistent gap in most of these studies is the lack of explainability, which our work perfectly addresses. We used a balanced dataset of 25,000 labeled cervical cell images divided evenly into 5 categories. Here we can see the 5 categories. The dataset closely mimicked the real-world variability found in medical imaging. Preprocessing was essential to standardize these images. All images were resized to 224 into 224 pixels, normalized for better model convergence, and augmented using techniques like rotation, flipping, and zooming. This helped expand the training set and improve the generalization capabilities of our models. The dataset was split into 80% training, 10% validation, and 10% testing. We explored 5 popular CNN architectures: VGG19, Inception V3, ConvoNet Base, Exception, and MobileNet V2. Each model brings unique advantage in image classification. MobileNet V2, known for its lightweight architecture and efficient computation, emerged as the best performing base model. We fine-tuned MobileNet V2 by leveraging pre-trained ImageNet weights, freezing the initial 75 layers and customizing the upper layers for our specific task. We added a global average pooling layer, a dense layer with 256 neurons using a sigmoid activation functions, and a dropout layer to prevent overweighting. We used the Adam optimizer with a learning rate of 0.0001 and implemented early stopping and learning rate reducing callbacks to improve training stability. Our results clearly demonstrated the superiority of the tuned MobileNet V2. It achieved an overall accuracy of 99%, outperforming all other models across all matrix precision, recall, and F1 score, each at 0.99. In comparison, standard MobileNet scored 97%, Exception 94%, and VGG19 only 78%. The training and validation loss curves showed consistent improvement with no overfitting, and the accuracy curves mirrored this trend. Additionally, the confusion matrix confirms that model's robustness by showing a high count of true positives and true negatives and relatively few false predictions. To ensure that the model's predictions were not just accurate but also understandable, we incorporate explainable AI techniques. Line highlighted the superpixels in the cervical images that influence the model's decisions the most. For instance, in abnormal cell image, line pointed to irregular cell borders and internal structures. Similarly, we use saliency map to generate heat maps of inferential image regions. These maps showed where small changes in pixels values would most affect the model's output. For clinicians, the visual explanation builds confidence that the model focuses on medically relevant features such as abnormal rather than irrelevant background patterns. This fashion of performance and transparency is vital for real world deployment. In conclusion, our study successfully demonstrated the potential of deep learning in cervical cancer diagnosis, particularly through the tuned MobileNet V2 model, which achieved an outstanding 99% accuracy. More importantly, the integration of line and saliency maps added a layer of interpretability that is essential for clinical acceptance. Looking ahead, we aim to expand our dataset, include multimodal data such as patient history or genetic markers, or making a real-time diagnostic interface. This is the acknowledgement part. That's all from my part. Thank you. Hello.
Hello. Thank you so much for your presentation. Ma'am and sir, do you have any questions?
You have used only 3 papers as a reference for your work, and that was like one paper was from 2020, the other 2 were from 2022. So, don't you think it's 2025 and some papers could have been taken from 23, 24 as well, which could have impacted your work or the direction uh, of the work or the kind of techniques you worked on?
Ma'am, in the main paper, we have used reference from 2024 papers also for the presentation part.
Okay, so I could not see it here, and moreover, I think there must have been surely must have been some difference in that paper of 2024 which you have referred for your work.
Okay, ma'am.
And secondly, don't you think for explainable AI, particularly in your case, SHAP could also have been, used instead of only Lime and the other one?
Yes, ma'am. For further work, we can also use GradCam or other explainable AI.
So what's the main reason of using only these 2?
There is no specific reason actually. Just used it.
But actually, when we validate the results and when we combine algorithms or when we propose a model, in that case, it becomes really, important either from
Yes, ma'am.
literature review perspective or your own experimentation perspective. It becomes really, mandatory to have specific logics and reasons behind taking up something, right? We cannot just casually uh, take any algorithm or combine algorithms together and just can prove that this has improved the results. So it doesn't add any credibility to your work. Yeah. So this is the feedback from my end. Thank you.
Thank you, ma'am.
Sir, do you have any questions?
Yes, mine is just a recommendation on what Dr. Neha has just spoke about, that you cannot randomly just choose something because it's something you like to use. So there should be a rationale behind what you want to use it for based on the logic coming from the literature review, which is backing why you say you want to use Lime and Sharp. So also over and above that, using Lime, Sharp, and other models, it's a good thing, but also you must safeguard the biasness of our algorithms and how this explanation are happening using the AI explanatory models. So what can be used as a best practice is to also monitor that particular process manually, so also by involving a team of some experts individually, so to monitor all of those algorithms against the biasness, which is a deep or a burning issue as we speak. Also be transparent again of your algorithm, maybe putting it on the public domain so that people maybe can scrutinize it and see how you have dealt with the biasness. So that's my contribution for your work. Thank you.
Okay, sir. Thank you.
Thank you so much. So we'll be moving on to the next presentation. Next, we have Kethleo to present the paper titled Enhancing Critical Infrastructure Protection Through IDS in 5G Networks, Leveraging RAG Technology. Are you there? Okay. Yeah, you may please begin with the presentation.
Yes, I'm here. Okay. Good afternoon, everyone. My name is Katleo Siatlolo, and today alongside me, I have my lecturer, Dr. Kuto Libia. And today, I just want to discuss enhancing critical infrastructure protection within the 5G networks. Specifically, we will look at retrieval augmented generation, or RAG technology, how it can significantly enhance capabilities of intrusion detection system. To the next slide. So this will be the agenda that I'll be covering, but just to save time, I'll just go to the introduction. So we are living in an era of rapid digital transformation. Critical infrastructure, particularly in the energy sector, with the rise of smart grids, is becoming heavily dependent on digital technologies that use high-speed, low-latency connectivity, which is offered by 5G networks. While this brings efficiency, it also expands the attack surface. Cyber threats are not just growing in frequency, but they are also growing in complexity, ranging from DDoS attacks, data breaches, and potentially physical sabotage. The very architecture of 5G includes network slicing, virtualization, which introduces new vulnerabilities that we must address proactively. Which brings us to the main question. Why is our existing security measures like a traditional intrusion detection system not sufficient? We know that a traditional IDS often relies on predefined signature of known attacks. This makes them just simply reactive and unable to effectively detect zero-day threats. Furthermore, the sheer volume and the velocity of the data generated within the 5G network can overwhelm the systems, leading to missed detections. Traditional intrusion detection systems often suffer from high rates of false positives, which can burden security teams and potentially masking real threats. Most importantly, in the face of sophisticated multi-stage attacks, traditional IDS often lack the speed and the contextual understanding that is needed for an effective and timely response. This brings us to the new approach, using retrieval augmented generation, or rather RAG. RAG represents an advancement in artificial intelligence, specifically combining two strands of approaches. Number one, retrieval-based methods, which can help us in accessing and pulling relevant information from vast databases and knowledge bases. Secondly, we have the generative models, which can be crucial in creating a context from relevant text or insights. RAG, we know that it uses massive data sets, which can include historical incident logs, real-time threat incident feeds, a detailed network traffic. We can use this by processing it using natural language processing and some machine learning techniques. When integrating an intrusion detection system with RAG, we create a powerful synergy. This significantly improves the detection by identifying subtle patterns, anomalies in the signature-based system, which would be often missed. By providing real-time, context-aware insights and even actionable recommendations, RAG enables a much faster, more effective incident response. It achieves this with a few false positives as it develops an understanding of what constitutes a normal versus a malicious network behavior. Most importantly, RAG can provide us with a contextual understanding by correlating this information from data from these diverse sources such as network traffic, security logs, and external feeds. which can allow security teams to make better informed decisions. So let's consider a practical scenario right now. I'll just go through a case study that we covered in our research involving a smart city's 5G-enabled energy grid. Attackers normally would identify and exploit a weak encryption mechanism in a widely deployed smart meters. The city's traditional intrusion detection system that is monitoring the 5G network is often overwhelmed by the amount of volume of legitimate traffic from thousands of devices, which fails to distinguish the attacker's malicious network in the network. This allows the attackers to manipulate billing data, causing even localized power outages, impacting critical services such as transportation and hospitals. The attack can even escalate as the attackers can access the grid's central control system. They can steal data, inject false commands, which can lead to severe disruptions before the intrusion detection system can finally flag this activity. But then we know that this can be rather be too late for the damage that it can be caused by attackers. So now, how can REG have changed this outcome? A REG enhanced intrusion detection system will be continuously monitoring in real time. Using threat intelligence, they will be potentially flagging the known vulnerabilities in the smart meter in the encryption system much earlier. As the attack starts, REG would analyze the anomalous traffic patterns, retrieve information about similar past incidents or known attack techniques. Two, like we said, we would generate context-rich alerts that will be generating high probability of the targeted network and not just random noise. This allows for a much faster, more accurate detection, which enables security teams to initiate a targeted response, which in this scenario could be isolating the compromised meter and preventing attackers to escalating the access to the control center, therefore by minimizing or even preventing a widespread disruption. So integrating REG is not a simple switch, right? It requires a structured approach. We proposed a methodology involving 4 key phases, which begins with vulnerability identification within the 5G network and the connected infrastructure. This is also followed by a comprehensive data collection and pre-processing. So in this regard, gathering the right data is crucial for the REG's effectiveness. Step 3 will be the core phase, which involves the REG training and integration. Teaching the model how to understand the network's specific patterns and connecting it with the intrusion detection infrastructure. We can use APIs in this regard. And lastly, in the last phase, we'll move this system into time monitoring and response phase, where the combined REG intrusion detection system will be actively scanning the network and protecting it. So let's just dive a bit deeper to the key pieces, right? Step number 1, vulnerability identification. We would use tools like Nmap to scan the network. Secondly, we can apply threat modeling techniques or frameworks like Stride. We can conduct regular vulnerability assessments using tools like Nessus. Step number 2 involves the data collection, which requires gathering diverse data logs, system logs, external threat feeds, historical incidents data. Followed by that, we need to do some cleaning, normalizing, and structuring this data. For the core phase of our model, which involves the training and integration, REG is usually trained on this curated data.
I'm not able to hear anything. Is there any
Hello,
problem
are
with
you
this end?
speaking? Ketlu, are you speaking?
Severity assessment. This combined intelligence will enable us to have a faster manual or automated response. So the key benefits of adopting this REG enhanced approach for critical infrastructure is substantial. We significantly improved threat detection accuracy, especially in novel or complex attacks. The incident response becomes faster, more efficient because the real-time context insights that were provided by the RAG model, which will enable security teams to reduce their burden from the false positives, allowing them to focus on genuine threats. The system will provide a much deeper, holistic understanding of a threat landscape, ultimately leading to an increased resilience for our essential services. However, implementing RAG with the intrusion detection system has its challenges. Number one, integration itself can be complex, requiring careful consideration of the data compatibility, processing power, potential securities that are associated with integrating AI systems. The normal black box nature of some AI models raises some valid concerns about the transparency and the potential bias in decision making, which needs ongoing research and mitigation strategies. The effectiveness of RAG is fundamentally dependent on accessing high quality and relevant and well-maintained data. And lastly, handling the potential sensitive network and operational data requires more privacy techniques, preserving techniques, and good governance. So in conclusion, integrating a RAG, a retrieval augmented generation technology, represents a significant leap forward in intrusion detection systems, particularly in a demanding 5G networks protecting critical infrastructure. RAG directly would address many of these key weaknesses that the traditional IDS intrusion detection system currently have. While these challenges remain, particularly around the implementation, complexity, AI ethics, we see the potential benefit to make the RAG an essential tool to safeguarding our energy grids and other critical infrastructures such as transportation and hospitalization.
Thank you so much for your presentation. Ma'am and sir, do you have any questions?
Yeah, I think I have come across with such work in which they have integrated, RAG and IDS. So I'm not pretty much sure about the kind of novelty of your work. So, and moreover, I cannot see any references also from which your work is inspired. So, can you put some light on these 2 points?
So we did do some research and there were some current, yes, you are correct. There are some current systems that implement RAG with intrusion detection systems, right? But then one of the things that was out of scope, it was that I don't know artificial intelligence currently, and we got some recommendations of using Lime and Sharply so that we can include explainable AI in our project. So to generate the context aware for security teams so that they can have a better understanding of what's actually happening in the network. So yeah.
No, that is absolutely fine. XAI is okay in terms of, giving a more, I would say, user-friendly approach or scenario. But as far as the basic work done is considered, in which, we propose some kind of refinement in the current system, considering the loopholes or the shortcomings of it, I think in real life, 5G systems are already coming up with so much security or, considerations regarding the improvement of factors which were not there in the traditional systems. So, in that case, I have a doubt that whatever, challenges you shared with us, that it is lacking in the, current systems and the combination would provide some betterment. This is a little bit, not so promising for me. So I think you need to have a better understanding of things and scenarios by going through the review of literature extensively once more, so that you can, bring up some novelty in your work. This is my, observation. Okay.
No, thank you for that feedback.
Yeah, that's it from my end. Thank you.
So, do you have any questions?
Yes, I just want to firstly find out, is it for the master's or is it for the PhD work before I just give the recommendation?
No, I'm currently doing my honors currently, so yeah.
Okay, so if it's at the honors level, Dr. Niha, it is understandable, but also the student can also add, like you said, some other maybe new models, because now you're saying REC plus IDS, and then maybe you can just add some other models which are new to your analysis. Say, for instance, you maybe put something like your BART new models and your BM25 models. All of those models, you just compare them to your REC plus IDS. So from those comparison, you'll get your novelty, saying that maybe REC plus AI is much better than a REC plus IDS. So that will be your novelty. So you're moving with that novelty. Maybe it can push you to have more contribution for your masters and so forth. But at the honors level, it's understandable. But perhaps maybe we can take the recommendation from Doctor that you must also add some new models just to have that novelty of your work. But as it is, it will be a challenge. Thank you.
Thank you.
Thank you so
Yes,
much
so
for your.
you're absolutely correct. I too agree on that part. Yes.
Thank you so much for your presentation. So we'll be moving on to the next presenter now. Next, we have Aditya Gupta to present the paper titled Natural Program Synthesis in Haskell, Leveraging Refinement Types for Readable and Scalable Code Generation. Are you there?
Yes, just let me share my screen.
Yeah, you may please begin with the presentation.
Okay, sorry about that. Hi everyone, thank you for being here. My name is Aditya, and today I'll be walking through our research on natural language program synthesis in Haskell. The work has been done by my colleagues at Amazon. We are software engineers and managers at Amazon and AWS. And our goal of this project is to make code generation smarter and not just correct. So we do a lot of code, and the idea is, can we somehow make it better and do more auto generation of code even in the age of AI? What does coding programming in general provide us to help engineers make better decisions? Quick note, the views or the presentations in the paper are our own views. They do not reflect the views of Amazon or AWS. Okay, so what is the motivation behind these papers? So developers do a lot of struggle. We are all developers, the people writing these papers, and have been for all of us at least 10 to 15 years. We are often torn between writing code that works and code that is clean. That is a big dilemma. And sometimes you just want to transform a list, but you end up debugging for an hour. And that's where programming by example helps. You give the system examples of what you want, and it writes the code for you. Most PBE, and PBE is an industry keyword that stands for programming by example tools, they stop at correctness. Our focus is to go one step further to generate natural idiomatic code that you won't hesitate to check into a shared repo or actually production code. So that is our aim. It should not just be correct, it should be able to go into production as is. Okay, so what does this paper propose? A synthesis system that takes your input-output examples and automatically generates Haskell code. So you just provide a sample input and you provide a sample output, and it will generate your code. It's not as simple as that, but that is the broader idea. More than that, it uses refinement types to rule out bad solutions early. It also works well with user-defined types and libraries. Most importantly, it tries to use clean Haskell idioms like map, folder, filter, so the output is immediately reusable. So let's say you're working on a package in whatever company you are, and you start feeding it inputs and examples into your Haskell system or the tool that we've developed. Eventually and very quickly, the Haskell system has created an internal language model of what your code package is like. So even on your first try, it's giving you the right answers, but over time, and we'll talk about it later how quickly it works, it'll understand your package or your system. So now it has already created some internal mapping or internal functions of what your system looks like based on your input output in the past. So successive code requests that you're making to the system will become radically faster and correct, and something that you can check into repos. And this is even better than AI right now. We are not doing a direct comparison with AI, but AI is doing search. And right now, what we are trying to do is we are trying to do lookup. And so you're looking up in your code of how it works. So to clarify, what is PB or programming by example? You tell the system, this is a very basic example to understand how the system works. You tell the system that 1, 2, 3, this is a list, should become 2, 4, 6. The system figures out that the most natural solution is map into twice. So 1 into 2, 2 into 2, 3 into 2. This is powerful because it means even someone who doesn't know how to write Haskell can use this tool to generate correct idiomatic code. And of course, as your systems become more complex, it will work for more complex examples as well. So PB sounds great, but there are challenges. First, the number of possible Haskell programs is enormous. Second, many synthesis tools generate code that's technically correct but very ugly, and you don't want to commit bad code to prod. And like deeply nested recursion, when a simple map would do, it's often giving over-engineered or complex examples. So there's a clear need to bridge this gap between machine-generated code and what humans actually like to read and write. And that is sort of also what makes our tool unique. The first part is hard, but we feel the second part is even harder, and this is where we bring value. Our tool tries to address these problems by leaning on Haskell's strength, and that is also a reason why we've chosen Haskell. It favors higher order functions. It uses liquid Haskell for refinement typing, and it ranks solutions that use user defined functions or recently imported modules higher. So, I mean, whatever you've imported recently sort of start getting ranked higher. And if your latest package, let's say you imported is 2025, 2024, then the versions in 2021 or 2 in your config file in your code get sort of a lower ranking, and newer versions get a higher ranking. This makes the code, final code, not only correct, but very close to what a seasoned Haskell developer would write. And this is what we saw from our daily usage as well. Although um, so we don't do a lot of large scale code in open source on Haskell. So unfortunately, can't share proprietary code, but we did started seeing these language the language models that we had created. These are not large language models, these are just language models that we had created started performing better, and that is what became the motivation to do a research paper about it as well. Okay. So why Haskell is ideal? Specifically the perfect fit, and that is what lends itself to this sort of idea. It's functional, it's typed, it's expressive. You can write very complex logic with very little code thanks to higher order functions. And liquid Haskell lets us add refinement types, which makes reasoning about correctness even easier. So I think this is very important. Python is somewhat similar, but Haskell is like 5x Python in that sense. Python is also functional, typed, and expressive, but Haskell allows it to do a lot more. And that is why what eventually started as a proof of concept, and then we eventually developed into a system and then a tool that was replicable. The further next step for this paper could be adapted to Python. It has some challenges or why Python is not ideally suited, but that is the logical next step for this paper to do. What are refinement types? They are regular types, but with logic built in. And this is inbuilt in Haskell. And this is very critical to how the system works. So instead of saying this is an integer, we can say this is a positive integer. This kind of extra information lets us filter out many bad candidates during synthesis. And although it sounds very simple, if you're just saying something as an int versus something a positive int, but if you realize most languages, even C, C++, Java, these are not static types. So it's very hard to define a system of what values it can take unless you specify it in array or give a specific value permissive. With Haskell, these things are very easy. And that is why the user would be motivated also to share a programming by example kind of thing, where I input and output, because they have to give one line. It's not large lines they're giving. It's a very simple one line program, and then the system starts learning based on what you've told it. So yeah, this is just one level thing. So what are high level? So the high level system architecture, there are four phases. Two are the most important phases. The first phase is the offline phase. When we run the offline phase, the system indexes available functions and tags them with types and refinements. Then in the online phase, the system takes the user's example and searches through that database for programs that match the example and the refinement constraints. It then ranks and returns the best fit. This is critical. This is, if you were to take an AI example, this is what the model training phase looks like. And although AI can make it better in some sense, but then AI will need manual annotation. And we are working with AI to improve it, but we are seeing that those are two different things. You don't need AI to do this. It This is for developers who already know how to program. This is not for someone who's unaware of how programming works, and that is where AI sort of kicks in. So this is a problem that AI is not solving today. Maybe in the future, not today. So this is just an example, again, a very simple example deliberately chosen to represent how the system would work. If there is a list 1, 2, 3, and the output we want is 1, 1, 2, 2, 3, 3, the system synthesizes concat map or replicate 2. So these are built on existing libraries. It's a very natural solution replicate that makes 2 copies of each IM, and concat map flattens the result. So what is critical to understand is, although these examples might seem overly simplified, they have to be, because they are non-context specific. They're just talking to another person. They're not based on your program. The system is able to figure out what needs to be done here. And then of course it will give you a couple of options, and you can manually annotate and filter out each of the options. For most of the programming that happens in a built system, this is very critical, because all often time, let's say you're working with an API, you want to define what a response and request
Sorry to
structure would.
interrupt you, but you have 2 minutes to conclude your presentation.
Okay, sure. So these are just some more examples that I had. This is a very specific example that we worked on. This is for Utopia DSL, and this is for how in music these kinds of system would work. So we tested our system across many benchmarks, and in the related work section, I don't think I'll have time to go there, but we talk about how our system performs better than all the other benchmarks. This is how we frame the problem set. This is critical. So how the tool narrows the system state without pruning the system would try millions of combinations. Refinement types, which is a specificity of Haskell, helps us skip bad matches early. We also use input output size relations to discard candidates. Finally, we run a best fit search over ranked options so we can find usable solutions quickly. We also need a way to rank candidate programs. We look at how close their types are to what's needed. We give preference to user-defined or nearby functions. Let's say you want to make 1 plus 1 2. If you've defined that I want to do plus 1, then that is what we'll prefer as opposed to what we've learned from the library. These are some benchmarks we compared against industry benchmarks. Of course, our system performed better. The last one that you see is DSL, which is the Utopia or the music library. Music library performed significantly better than what's out in the world. The system isn't perfect today. By pruning the search space, we miss valid programs. User-defined types need manual annotation, sometimes manual input. Liquid Haskell isn't by itself perfect. There's no interactive feedback loop yet. It's all done through code, and there are relative areas of improvement. We've compared with other popular algorithms. Our system performs better than most of them most of the time, but of course there are some gaps where Myth or Synquid performs better. Those are the recent sort of industry leaders there. This is the last slide. To wrap up, codes is this is just about isn't just about making programs work. It's about making them usable, and that is very tricky. That's a NP hard type problem. Our system shows that combining refinement types with PB leads to clean, understandable output. And we are excited to expand this to other languages and improve automation in the system more interactive. Thank you, everyone. I'm happy to take any questions.
Thank you so much for your presentation. Ma'am and sir, do you have any questions?
Yeah, so Aditya, I think you've somehow answered most of the questions which were there on my mind while going through your presentation. listening to your presentation rather. So, but I think there are a few things which I would like to ask you. Firstly, I'll begin with the simple one. Uh, I could see five authors there, in your paper.
Yeah.
So is it
Yes.
kind of some project which you're working on, or this is just a kind of, research work that you want to take up, or you have already like registered yourself for any kind of research work?
That's a good question, ma'am. Because of our company's policies, I cannot share a lot of details, but this is a research project. This started as a POC, proof of concept. We were surprised by these results, and that is how we've tried to build on this system. And that system actually worked. So then we decided the only way to get it out in the world is to publish the results. So this is Amazon's approved, like we get Amazon's approval to publish this paper, and all of our affiliations are Amazon and AWS. But I'm really sorry, I cannot talk a lot about how
That's
what this project
absolutely
is.
okay. I just
Yeah.
want to know about like how the group has been formed of you five and how the work was divided among yourself. And more than that, see, whatever project we take up or any kind of research work, I think there has to be some background work which we need to do. Uh, as in your case, I can see like you were trying something and you thought of improving the system, and this is
Yeah.
how it must have started, isn't it?
Yes. So actually, the idea was AI is not giving outputs that can be used as such in code. And plus, the second option was the code libraries that we write internally for any enterprise system somehow work better than what AI and let's say new developers do. So, what was the gap there? The gap was we are creating these automation scripts in a way like industry wise, not just for Haskell, in a way that do this for us. So, why can't we just, create a tool that does this for us, and that tool is why it hasn't been created because there are not a lot of developers in Haskell, which is the language that's most easy to create this tool in. And so that's what we've done. Like this is solving our everyday problems. The only limitation is limited to Haskell for now, and most of
Okay,
the code
and
is in Java.
I couldn't, yeah, yeah, and I want to know about the how the group has been formed. Like the company
Yeah.
delegated all five of you for this,
No,
or
no. No, yeah. So there was a original proposal on who want to do. So there was a proposal floated out by our primary author, Aditi Chaudhary, and her proposal was, are people interested or are any people doing work on automated code generation? So I was one of those people, and I reached out to her that I'm interested. So I did the coding part or creating the system, and then we found other people who could do the testing. So the rest of the three authors are who could actually test the system and iterate on it. So that is how we found like there is a research proposal
all
group in
right.
Amazon where people can put out their ideas.
Hmm. All right.
Yeah.
And how about the challenges which you faced in, refining the system, or I would say integration of some components? So wasn't it a challenge, or like the system allowed you and the, management allowed you to try everything on it?
Yeah, so we didn't test it on Amazon's code base. That is not something we are allowed to do. So we tested it so there were thousands of packages on GitHub. So I just set up a Python model where I used my system and then tested it out on multiple GitHub packages. So that didn't pose a challenge. The challenge was initially setting the code up. I've had a lot of experience with automated code generation. I have like 5 or 6 papers in this domain over the last 6 or 7 years. So it wasn't that big a challenge to get started. The only challenge was working with Haskell because I did not have a lot of experience with Haskell. And my responsibility was doing the backend tool creation part. Aditi who was the original proposer of the idea or the principal investigator. And then the other 2 or 3 authors, they were responsible for testing and iterating on the system.
And you didn't
So
feel like trying it on some other, platform or system instead of Haskell if you're facing so many,
um,
problems?
yeah, I'm the Python system now. It's been the last 5 months. It's actually very hard. It will take me another 5 to 6 months to build it out completely. The challenge is Python, even though very good, just like Haskell, Haskell has refinement types and Python doesn't. So so it becomes very hard to define a large input, reduce it down to something that Python can understand and the users want to use. So in this tool in Haskell, users can actually use. With Python, the issue is they will have to provide long inputs and long outputs, and users don't really want to spend a lot of time doing that. So it is doable. I'm not sure how usable it will be in the actual real world.
Okay, and keeping in mind the the pace at which uh generative AI or maybe agentic AI is taking up the industry. So don't you think by the time you will come up with some concept in a limited way, things will be way ahead of whatever you are doing right now, or you would be
Yeah.
ended up doing in a few months, right?
That's a great question, ma'am, actually. So the idea here is that AI, we are using AI. Like when we use this tool, we use AI first to create the input, second to create the output, and then to enrich the memory. This is the basic tool. So what AI has to be done is AI has to be adapted to this tool. So today, if you, let's say, use any model, you train a model on Bedrock, you just take your code package, you tell Bedrock, please learn from this package, and then I will start asking you questions. Now, your new input will be you go to Bedrock, you say, this is my code package, and this is my model of how I will interact with you. And now learn this, and I will talk with you. So, this is where this tool comes in. Today, there is no way to tell Bedrock because Bedrock has been, or let's say Llama or Claude 3.7 has been trained on all the world's code. There is no way to tell it how to do this structuring. So, very good prompt engineering tells an example of, let's say, write me an email as I am the researcher and the audience is X. So this is what it's doing that. So this will never be outdated. This is very important. Now, of course, maybe in a couple of years, yeah, AI is able to do that. It's not there yet.
Yeah, so if you're that much confident, I would say incorporate a kind of background work or comparative study which you've done when you
Hmm.
say that to just to add some weight to your work, right? Thank you
Yeah,
so
that's a good
much.
point.
Yeah.
Yeah. Thank you
Thank
so
you.
much for these are great questions. Yeah.
Yeah. Sir, do you have any questions?
Yes, although I'm not that much clue up with Haeckel, but I just want to find out how are you going to deal with the issues of scalability in a sense of scaling for programs, synthesis, especially for large programs, and then also how you're going to deal with the reliability of those models, ensuring that whatever is generated is readable and maintainable. Also, the correctness, ensuring that whatever program is generated, it meets a certain specification and also it is correct on the same time.
Yeah, so I think those are great questions, sir. So there are three questions. One is around scalability, one is around correctness, and one is around actual usability in production code. So in terms of scalability, the code actually scales pretty well. So the idea is, let's say you have 1 million lines of code or you have 10,000 lines of code. So it isn't like, so it's just based on logical structures of refinement types in Haskell. So Haskell code has to be structured in a way. So you have to define a function. Even in your basic code, you have to define what this variable is of type and what this function is of type, what the possible input output is. So the for this model to learn on that, it doesn't matter how much the code is. The actually what's unique is more the code, the better the model is, because it's not a large language model, it's learning the input output types. So inside it's creating a decision tree of what each decision looks like. So better the decision tree, more is the output. I think the second question is more harder to answer, which is it usable at the end? That is difficult in the sense that user will have to make it usable. Like you will have to spend time with it, giving it examples, input and examples, or whenever it generates an internal mapping, they might have to manually annotate it. And this is where AI is helping a lot. You tell AI, this is the input and example I want, and then AI calls this tool at the backend, then does a that is called repeated processing, or the O1 models in Chat GPT, which do repeated reasoning. They reason it again and again, then figure out the final model. So this gives the framework to that reasoning. I think the third part of your was, how do you ensure correctness? So correctness,
Yes.
surprisingly, we are already there on the benchmarks there. So there are 5 previous models that exist, and our model builds on top of that because we are doing usability and not correctness. So correctness is there in the system, but of course some manual annotation is needed to figure out if the answer is right or wrong by the user.
Yes, 100%. So also you spoke about the tools which are using. I saw you spoke about the liquid Haskell. Is there any
Yeah.
other tools or frameworks which you combine with this liquid Haskell?
No, actually no, sir, because Liquid Haskell is the primary. So Liquid Haskell, I think, came out in 2015, and since then
Yes,
it has been what, yeah, most Haskell developers are using. I honestly don't even know if there are any other tools,
yes.
but it's like
No,
the default that, yeah, we work on. Yeah.
yes, but perhaps if
Does
you can check the DGen and the Hermit, I think also it's part of your frameworks and tools which can also be incorporated there. I'm not the domain expert, but I'm assuming that
Yeah.
it can also assist you.
I see. Yeah, sure, sir.
Yes, just jot them down, DGen and that Hermit, and
Oh,
then you can
Degen.
just
Yeah,
check.
yeah, yeah. Okay,
Yes,
I see what you're talking about. Yeah, Degen, sir, we've
yes,
used. Degen does not give us all the refinement types. So Liquid Haskell, Degen is for a different problem solution. Liquid Haskell is
yes.
more generalizable. But yeah, I will do some more research on what you suggested.
Okay, good luck with the good work.
Yeah, thank you so much.
Thank you so much for your presentation. So we'll be moving on to the next presentation now. Next, we have Vanda to present the paper titled The Role of Online Reviews, Brand Images, and Menu Visuals to Increase Customer Retention to Buy in Restaurant. Are you there?
I'm here, madam.
Yeah, you may
Yeah,
please begin with the presentation.
sure. Okay. Good afternoon, everyone, from midnight time in Jakarta, Indonesia. Welcome to my presentation at the ICTIS New York 2025 virtual conference. My name is Wanda Shoki Mikola, and I'm honored to present my research under Bina Nusantara University. This article provides a structured analysis of the factors influencing customer intention to buy in the restaurant industry. It begins with an introduction that sets the stage for the research. The literature review explores existing studies on customers' behaviors, owner reviews, brand image, and menu visuals. The hypothesis and research framework sections present key research assumptions, while the methodology explains the research design and data collection process generated by the results showcase findings. The study end up with insight in the conclusion and limitation sections. The restaurant industry constantly evolving due to changing customer preferences and technological investments, such as contactless payments and online ordering. Customers are primarily drawn to restaurants based on three key factors: visual appeal and ambience, menu quality and variety, and brand image supported by online reviews. Online reviews act as a form of social proof, significantly influencing customer decisions and shaping a restaurant's competitiveness. This research investigate the impact of the online reviews, brand image, and menu visuals on customer intention to buy in the restaurant business. This research explores key factors influencing customers to buy in the restaurant industry through four main perspectives. For the first one is online reviews. Customer reviews significantly shape purchasing decisions, with negative feedback carrying a stronger influence than positive ones. High quality and socially visible reviews help build trust and increase intention to buy. And the second one is brand image. Restaurants' brand image affect customer trust and loyalty. A strong brand image aligned with consumer expectations, enhancing their likelihood of making a purchase. Theory of recent action suggests that positive brand attitudes drive purchasing behavior, while the Veblen goods theory highlights how high-end branding can increase appeal. The third one is menu visuals. High-quality image and aesthetically pleasing designs boost customer interest. Visually appealing menus enhance appetite and reduce cognitive effort in decision making. And the fourth one is intention to buy. customers' intention to buy is shaped by a combination of brand image, menu visuals, and online reviews. Positive reviews build trust, while strong branding and enticing visuals create a compelling dining experience. Okay, this research proposed four key hypotheses to examine the factors influencing customer intention to buy from a restaurant. For the hypothesis one is online reviews significantly impact customers' intention to buy, as reviews shape perceptions and trust. The hypothesis two is brand image influences purchase decisions, with strong branding enhancing trust and customer confidence. The hypothesis three is menu visuals play a crucial role in attracting customers, as high quality image enhance appeal and decision making. And the hypothesis four, a combination of brand image, menu visuals, and online reviews collectively influence customer intention to buy, suggesting an interconnected effect of these factors. This hypothesis aim to understand how customers' perceptions are shaped and how restaurants can optimize these elements to drive intention to buy. This study employs a quantitative approach to examine the relationship between customers' intention to buy, brand image, online reviews, and menu visuals. The research focuses on fast food restaurant customers in Jakarta using a random sampling method with 200 respondents selected based on the Hair formula. For data collection and analysis, both primary and secondary data sources are utilized. The study applies structural equation modeling partial least square, as abbreviation is SIMPLS, to analyze complex causal relationships among variables. The key research indicators includes online reviews with factors have ratings, emotional appeal, engagement. Brand image with factor have a recognition, reputation, attractiveness, uniqueness. And menu visual with factors have clarity, aesthetic, and content engagement. And the intention to buy with factors have price sensitivity, authenticity, promotions, food and service quality, customer satisfaction. This methodology provides a structured approach to understanding consumer behavior in fast food restaurant. For the result, the research finding confirmed the validity and reliability of the measurement model, with CR values exceeding 0.6 and average above 0.5. Additionally, the discriminant validity meets the Farner-Rucker criteria, ensuring construct differentiation. In the structural model, the R2 value of 0.799 indicates a strong explanatory power. The effect size F2 analysis reveals that menu visuals have a significant impact, while online reviews and brand image show smaller effects. The predictive model validity is confirmed with K2 is bigger than 0. The key findings includes brand image and menu visuals significantly increase customer intention to buy. And the second one is online reviews do not significantly impact intention to buy, aligning with past research that suggests reviews rating alone are less influential. What is menu visuals play a crucial role in shaping customer decisions, highlighting the importance of sensory appeal and visual marketing in the fast food purchasing behavior. Statistical analysis confirms that brand image with a p-value same as 0.000 and menu visuals with p-value same as 0.002 are significant predictors of intention to buy, while online reviews with p-value same as 0.018 do not have a statistically significant effect. These insights emphasize the importance of branding and visual appeal in driving consumer behavior in the fast food industry. The study reveals that in Jakarta restaurant industry, customer intention to buy is not significantly influenced by online reviews. Instead, brand image and menu visuals play a more crucial role in shaping purchase decision. To maximize the impact of online reviews, restaurants should consider offering incentives such as free desserts, voucher, or giveaways to encourage more positive engagement. However, there are limitations to this study. Since it focuses only on Jakarta, the findings may not be generalizable to other regions. Additionally, relying on quantitative data and random sampling may not fully capture the depth of customer motivations. Future research should explore stratified sampling and qualitative approach for deeper insight. Conduct longitudinal studies to track long-term trends and consider external factors such as market conditions and competitor activities. I would like to express my gratitude to Bina Nusantara University and ICTIS New York 20 and 25 for this opportunity. Thank you all for your time and attention. If you have any further question or would like to connect, please feel free to contact me. Additionally, my research is available in the Zenodo repository. Thank you once again, and I look forward to any question or discussion.
Thank
Thank
you
you.
so much. Thank you so much for your presentation, ma'am and sir. Do you have any
Yeah.
questions?
No questions from my end.
Sir, do you have any questions?
Yeah.
Yes, can we just go to the conclusion? The last slide before the thank you slide.
Conclusion.
Yeah.
Yes.
Wait a minute.
Slide number 8. Yes, just click on
Okay.
it.
This is conclusion.
So you on your first bullet or first point there, you say that customer intentions to buy in the restaurant industry is not significantly influenced by the online review. But I think the statement it's partially true, because now people time and again they will take selfies when they're in the restaurant, and then after that they will give their reviews. Especially celebrities will always take some pictures, especially when they're traveling abroad. They will recommend this particular restaurant based on their feeds. If they're putting it on their Facebook, Instagram, and socials, then that's where the restaurant will get more reviews, especially from that particular angle. So I suggest you also look at their online reviews from especially the socials, because it's the current phenomenon as we speak. That's my contribution. Thank you.
Yeah. Thank you.
So
Thank you
much for your presentation. So I would just like to ask, do we have Elvid to present the paper? Do we have Elvid to present the paper? Do we have Syed to present the paper?
Yeah.
Okay.
Yeah.
Okay. So with this, we'll be ending the session. I would sincerely like to thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 6 to 7 months. So kindly cooperate with the team of ICTIS 2025. Before ending the session, I would like to take a moment to thank our session chair, Professor Elias, for chairing this session. Sir, would you like to share a quick closing remark with us?
Yes, this was just an interactive and a very robust session just we had, and all of the best with the participants in their research endeavor. They should also be cognizant of the age which we are in, the age of AI. They shouldn't be left behind. Always research about what is happening in their domain and be up to date. Good luck with your research, and I thank you for the invite.
Thank you so much, sir. This is a token of appreciation. I would also like to thank Neha Tiwari, ma'am, for chairing this session. Ma'am, would you like to share a quick closing remark with us?
I'm delighted to be a part of this session. And yes, every session seems to be contributing to your learning and knowledge part. And I came across with many new ideas, and it was good to see people doing so much good in their respective areas. Looking forward for many such other future conferences sessions. And congratulations to you, Anshika, for managing everything so well. Thank you so much. And
Thank
thanks a lot that, I got an opportunity to share the session with Sir, and through which I could, hear very, very important insights and remarks and questions for the participants. And it was a learning experience for myself as well. Thank you so much.
Thank you so much, ma'am. This is a token of appreciation on the behalf of whole team and of ICTIS 2025 and Global Knowledge Research Foundations and Partners. And before ending this session, I would love everyone to open their cameras for a quick snapshot. Everyone, kindly turn on your cameras for a quick snapshot.
Is it okay?
Thank you so much, everyone, for your valuable presence. Thank you so much.
Thank you very much.
Teachers,
Thanks a lot.
bye.
Bye bye, everyone. Thank you so much.
Bye.